Hello everyone, this is Official Sendo. Today I'm going to talk Leetcode 1838, frequency of the most frequent element. If you like my videos, please subscribe in my channel, and you can find the complete preparation leads in video description below, which includes all the problems categories and its corresponding videos. Let's look at the problem description first. If you look at the whole problems text, it's kind of hard to explain. So let's direct jump to the examples. So here we given an array and given a k. We are asking to doing some operations which to make some elements equal to another elements. So we are asked to giving a number when how many numbers the unique numbers we can generate after all the operations smaller than 5. So for the first examples, we can try to convert all the elements to 4. So which means 1 need to plus 3 to 4, and 2 need to plus 2 to 4, and the total operation will be 5. So which is meet the requirements, we can done the operation smaller or within 5 operations, and we obtain the maximum unique numbers, which is 4. So the maximum copy is 3 for this time. So for the second examples, as the answer mentioned, there is 3 ways to do that. We can make first 1 to 4, and this requires 3 operation. Then we have 2 4s in array after operations. We also can make the 4 to 8, it requires 4 operation. So then we got a 2 of 8s. Again, we can make 8 to 13. So here we have 2 13s. Those frequencies are equal, so we can pick each one. For the third examples, there's no way we can make one element to another. So here we can try to make 3 to 6, but it requires 3 operation, which is greater than k. And also we cannot make 6 to 9 because we need at most 3 operation to convert 6 to 9. Alright, let's look at how we can solve these problems optimally. So it turns out these problems can be solved by sliding window. Also, there is a little bit greedy ideals, including that I'm going to explain later. So here we have 2 steps. First, we sort the whole array in ascending order, and second, we maintain 2 variables. One is calculate the target sum, and other is store the actual sum, and we applying a general sliding window templates, which I will explain later, combined with examples. Here are giving examples. Start with 4, 13a and 1, and the k equal to 5. So after sortings, the array becomes 1, 4, a 13. So as a uniform sliding window template, we have a left pointer and right pointer. So we initialize left pointer as 0. Here we can directly initialize right pointer as 1, since the mass frequency will be 1 in any of array which is side it's not empty array. Since we can make sure we have 1 element at least, right? Then how we propagate the left pointer right pointers. So the rule is we will increase left pointers when target sum minus actual sum greater than k. What does it mean? So target sum means for any of sliding windows of arrays, if we want to convert all the elements to the rightmost elements, what's the target sum, what's the total sum of the whole sliding windows. So basically, for example, if we take 4 and 13, so we convert 4 to 13, and the total sum of this sliding window will be 13 multiplied 2, right? So we have two 13s. And actual sum means we just directly adding all the elements in the specific sliding windows together. So then their minus means how many operations we need to use to make the target happens. Then if this operation is greater than k, which means we need to shrink the sliding windows, right? So why I'm saying we use some greedy ideas in this method, because we only looking at the closest one to generate this operation. This is why we need to do sorting, right? So because for example, if we need to make all the elements to 8, we don't want to start with 1. We always want to start with 4, which is closest one, right? So you probably can feel these points later when I go through the sliding window as below. So yeah, let's dive in example. So we initial left pointer is 0, right pointer 1, and we're looking for the 1 and 4 for these sliding windows. So as explained, target sum is 4 multiplied 2 is a. Actual sum is there, actual sum is 5. So a minus 5 is smaller than k, so we won't increment left pointers. We will record the maximum frequency for now, and then next we increment the right pointers. So next we extend the sliding window to 8. Then target sum is 24, actual sum is 13, and 24 minus 13 greater than k. So this is not a valid sliding window we are looking for. So we will increase left pointer to shrink the sliding window. So right now it comes as 4 and a. Its target sum is 16, actual sum is 12. 16 minus 12 equal to 4 minus and 5. So we will recall this frequency is still 2. Then next we move right pointer to extend the sliding window. Then target sum is 39, actual sum is 25. 39 minus 25 greater than k, so we will shrink left pointers. So left pointer is 2 and right pointer is 3. So right now we reach the end of sliding window a and 13. Then target sum is 22, 26, and 21. We obtain another valid sliding window, which is 2. So here we don't need to do any more, right? Because we want to find the maximum subsequence. So we don't need to shrink the sliding window again. So eventually we find our answer, which is the maximum frequency. All right, let's look like how we implement in the code. In the code, we first sort the whole array. We initialize max frequency is 1. So maybe we can add in one more initial condition. Say if the array is empty, we return 0, right? I think this is one of the corner case. And the left pointers we initialize say is 0, as we explained. We initialize actual sum. So use the first elements of the array. So be careful here, since we need to in worst case we need to sum all of the elements in an array. So we use the long to make sure it's run out of boundary. So we have a for loop iteration for right pointers. Then here we calculate the target sum, which is long as well. Then here we propagate the actual sum. So next we come our left pointer increment rules. So when target sum minus actual sum, we increment left pointers. Once we move left pointers, we need to do the reduce target sum and actual sum at the same time to maintain these two sums correctly. Eventually, we will find a valid sliding window after we shrink left pointers, right? So then here we can update our master frequency. Once we right pointers reach to the end of array, we will return the master frequency store. Let's look at the computation complexity and the space complexity. Space complexity is simple because we don't use the actual data structure, right? So it's big of 1. So what's the computation complexity here? So first step, we are doing a sorting, which is n log n. Then next type is sliding windows. How we look at the sliding windows complexity? One way we can look at this is looking by the right pointer and left pointers, right? So right pointers is always from 1 to the n, so it's big of n. So here we have n log n plus bigger of n. This is left pointers. And also another operation is increment the this is right pointers. This is right pointers. And another operation is remove left pointer, right? But we can observe that the left pointers also only move from 0 to n at worst case, right? So we are only looking for that combinations here. And the left pointers will never meet right pointers. So here we adding another operation for left pointers. So eventually, we will only take the maximum of the order plus here in the big O of notation. So the computation complexity for this method will be big of n log n eventually. So here is very small than the big O of n log n in terms of the computation complexity. Okay, that's all of today. I think you like this video. Please leave the comments and a suggestion so I can make better videos in the future. See you next time.